Hey Tech Math, here are the guided notes for 8.8. So let's read through the situation for Bellwork. Carol went back to her bank, which was offering 12% interest on a savings account. She asked very nicely if instead of having 12% at the end of the year, she could have 6% after the first 6 months and then another 6% at the end of the year. Carol and the bank talked it over and they realized that while the account would still seem like it was getting 12%, she'd actually be earning a higher percentage. How much more will she earn this way? Well, we could calculate that out, but I'd rather just talk about why she gets more, because that's actually more important to then later figuring out how much. So if she's getting 6%, remember how in the compounding interval we were talking about in the last video, when we compound interest, it's interest on interest. So because she gets 6% halfway through, she then gets her second 6% on the original 6%. So instead of just making 12% on what she put in, she will actually be making 6% on what she put in and 6% on what the bank put in. So she's actually kind of getting a little extra money, and that's why they decided not to give her that. So let's figure out how much more she would earn. Let's do it through this. Sometimes there are things that compound in an interval that is not annually. The last video showed you a compounding interval of an annual or a 1 year period, so annual periods. Now we're going to talk about non-annual, so maybe more than once a year. So consider a bank that compounds and adds interest to accounts k times per year. This is a variable. If the original percent offered is 12%, then in 1 year that interest can be compounded 1 time, with 12% at the end of the year, twice, 2 times a year like Carol was asking for, with 6% after the first 6 and 6% after the last 6. K is 2 because we've done it twice. 4 times, that's quarterly, or even 12 times monthly. And essentially, the more often you pay out your interest, the more you get paid overall. So intervals over which money is compounded is called the compounding interval. So the nominal interest rate is a number that resembles an interest rate but is really a sum of compound interest rates. So a nominal rate of 12% compounded monthly is really 1% compounded 12 times. And the really cool thing about the nominal interest rate formula is it's actually the exact same formula for a compounding of an annual rate. So let's go into our math type here and we're going to insert an equation. Excuse me. And it's going to be the exact same. We're going to say T, the total amount, equals the principal of 1 plus R over N, so that's our rate and our number of times it's compounded, all to the N times T. Now the last time we did this, I said N is always 1 if you're compounding annually. Oh, it's not going to let me put that in there. Will it let me do it now? Ah, yes, it will. Perfect. So my nominal interest rate formula is right there. Again, let's list out what each of those things is. Give me just a moment here. There we go. So T is the total amount in the account. P is the original amount invested. R is the rate as in rate. R is a rate, excuse me. N is then the number of times compounded. So if you're compounding quarterly or once every quarter, that is going to be a 4 for 4 times a year. And then little t is going to be the time in years that something is invested. So if I leave it in there for 5 years, your time is going to be 5. If it's if it's in there for 1 year, it's going to be a 1. So let's close out. So let's see what this looks like. What nominal interest rate compounded quarterly doubles money in 5 years? Wow, what a lot of information. So this says, what rate do we need if we're compounding quarterly? So the number of times something's being compounded is 4. That's 4 times quarterly in a year, so 4 times. My time is 5 total years, and I know that my total amount is just going to be 2 times whatever my principal amount is. So I'm going to leave my T as 2 and my P as 1. That tells me that it doubled, but it doesn't give me huge numbers to work with. All right, let's jump back into that math equation, and let's plug some numbers in here. So I know that I want my total to double. It's 1 plus r over n, which was 4, all to the 4 times, was it 5 years or 3 years? I have to remind myself. It was 5 years. So this is our finalized equation. And just like we did in our other equation, we're going to solve this. It's a little tricky, but essentially we are going to solve for r. So how do I do that? Well, I can simplify 1 to no longer be there. So I have 2 equals 1 plus r over 4 to the 20th. I can then put that 20th in. So let me throw another equation. Here, let's copy this one actually. Let's put it over here. And let's just edit this one. Is it gonna let me? Yeah. Oh, it won't. Okay, bear with me while I figure this out. I'm gonna put in a new equation so we can see what it looks like. So now we have 2 equals 1 plus r over 4 to the 20th. Well, I can simplify this to both of these. This is something we learned in algebra, so I'm not going to go over it real hard, but I can distribute this 20 into both of these numbers. So instead of having a 20 on the outside, I can have a 20 on the inside of each of these things. Now let's distribute it into both. 1 to the 20th is still just going to be 1. R to the 20th, r to the 20th over 4 to the 20th. I'm going to go to my calculator and put in 4 to the 20th. Let's see what that bottom piece becomes. 4 to the 20th. Oof, that's going to be a really big number. And then I know r divide r to the 20th over that. So r to the 20th, and then this 20 goes away. So essentially, I'm just simplifying like crazy. Once I get here, how do I get this 1 away? Well, I divide it. So if I divide 2, or I'm sorry, divide, I subtract. So 2 minus 1 is 1. And I'm left with 1 equals all of that. Now I know I may have lost you. This is just simplification. That is why I'm going to go a little bit easier at this point. I'm going to simplify this for you. So how am I going to do that? Well, when I try to get this 4 to the 20th to the other side, I'm going to multiply. So watch what really cool thing happens. In my opinion, it's really cool. We get r to the 20th equals 4 to the 20th. Now guess what? If their exponents are the same, it means their bases are the same. So we can actually just get rid of the exponents and see that our rate is going to be 4. Yeah, that's right, just 4. So in order to get our money doubled in 5 years, we need a rate of 4%. Now that was a lot. I don't expect you to be able to do that on the test. What I will expect is that if you can plug in all these numbers over here, you can solve for t. So that's going to be what example number 2 tells us. This was a really hard example, and I'm glad we worked through it together. Let's work through one that will be on the test, the easier kind. So this one says, how much will he have in 8 years? Okay, what will his total be if a time is 8 years, if his principal amount invested is $500, and the rate that he gets is 8%. Don't forget, we also need to know that it's compounded quarterly, so our N is 4. Let's take all that information now and just plug it into our formula. And then all we have to do is simplify. So, T equals, we started off with $500. We do 1 plus the rate, which was 8%, so 0.08, divided by the number of times it was compounded, so 4, to the 4 times, how many years was it? 8 years. All right, again, this looks really awful, but it's not, I promise. Let's throw this into our calculator. Let's simplify this together. 0.08 divided by 4. That is 0.02. All right, now I'm going to add the plus 1, so I get 1.02. I'm then going to take that to the exponent. 4 times 8 is 32. So 1.02 to the 32nd. That's like 1.8 something. So I'm going to find it by multiplying by 100. That is just simple algebra simplification. However, it's not always simple if you haven't seen it in a while. So if you're confused by how I'm doing this, come talk to me so we can definitely make sure that you are understanding how I'm getting that. All right, when I simplify it all down at the end of the day, the total amount he will have is $942.27. I did have to round here. If I wanted to find out how much interest he made, all I would have to do is take the total amount, the T, minus the original amount he invested. If I do that, I actually find out that over the course of 8 years, he made $442 in interest. That is a lot of interest, and you can see why we want to use compound interest and why we want to have it compound more often than 1 year as opposed to just once a year or annually. All right, tricky lesson. There's lots of examples and some great videos out there on the web. If you didn't quite see this one enough, just go ahead and type in compound interest over, compounded quarterly, compounded semi-annually, whatever you need to see. There's plenty of examples worked out. Otherwise, come chat with me and we'll make sure you get it.